So, what can we do? Well, so far we know that we can choose anything between -3 and 6, because anything past here is not equal to 0, or it won't give us a factor with a remainder of 0. So anywhere between here is our answer. So let's try the number 1. A very basic factor, and actually sometimes it actually doesn't work, and sometimes it does. So let's try it. 1 times 1 is 1, plus the -2 is -1, times 1, -1, -6, and look at that. 1 is actually a factor. How do we know? The remainder here is 0. Remember, this is going to be x to the 1 less power than your original problem here. Our highest problem power was x to the 7th. This is going to be x to the 6th, 5th, 4th, 3rd, 2nd, 1st, and then constant, then your remainder. So that means that x minus 1 is a factor of this problem, because that means that this is x equal to 1, or x minus 1 is equal to 0, which, as you recall, is how we find out, is what we get when we do our factoring. So, what do we do with this knowledge? Well, we've got the x minus 1. These numbers here at the bottom, these will be our new polynomial for the problem. So this will be x to the 6th minus x to the 5th minus 6x to the 4th. There's no x to the 3rd, minus x squared plus x plus 6. And the remainder we don't need to write down. So now what do we do with this? Well, from here we continue doing what we did before, and that's take the coefficients of our new polynomial and then convert them into the synthetic division problem. So that'd be 1, -1, -6, 0. Remember, you've got to put them all in order, and then if there's any missing ones, you got to still add those too, but you add them at 0. And then -1, 1, and 6. So let's try another one. What about -2? Let's see if that works. Well, we bring down the first one and multiply them together. Then we take that, multiply these two together, get 6. And check that out. It's also a factor. How do we know? 0 in the remainder. It doesn't matter what the signs are for these. As long as this is 0, that means this is a factor. And then we take this set here, and it's our new coefficients. So that's x to the 5th, -3x to the 4th, no x to the third or squared, negative x plus 3. So that is our new polynomial. Now what do we do after this? Well, to show that we've got this much done, it's generally shown as x minus 1, then our x plus 2. Remember, our negative 2 was actually the x. It's not the factor with x minus 2. It's actually going to be x plus 2, because we're getting the x, not the factor part. And then multiply by x to the 5th minus 3x to the 4th plus 3. And that is how the polynomial is being broken down. You can do this for the whole set if you want.